Climate change is redrawing the map of where toxic mushrooms grow, and this geographic redistribution is invalidating traditional foraging knowledge that kept people safe for generations. Mushroom species are appearing in regions where they've never occurred historically, bringing deadly unfamiliarity to places where local expertise previously provided protection. The deathcap mushroom provides the most documented example of range expansion. Originally native to Europe, Amanita phalloides has established populations across North America, Australia, and other continents. In North America, deathcaps were first documented in California in the 20th century, likely introduced with European tree imports. But now they're spreading beyond initial introduction sites, appearing in new states and provinces where they've never grown before. Local foraging experts who've spent decades learning their regional mushrooms suddenly encounter species they don't recognize. The traditional knowledge that worked perfectly for identifying local edible mushrooms doesn't account for new arrivals. Someone confidently foraging in an area they've known for 50 years might encounter a deathcap for the first time and misidentify it because it was never part of their regional mycological education. Poisoning outbreaks have occurred where local experts misidentified newly arrived species. People who successfully foraged their entire lives made fatal mistakes because the rules changed. Species that were never present became established, and traditional local knowledge became insufficient. The ecological mechanisms driving range changes are multiple. Warming temperatures allow southern species to survive in northern regions where winter cold previously excluded them. Milder winters mean spores that would have been killed by hard freezes now survive and establish new populations. Drought stress affects mushroom morphology, making identification harder. The same species growing under water-stressed conditions might look different from well-watered specimens. Features that foragers use for identification, cap size, color intensity, texture, vary with environmental conditions. Climate-driven environmental changes make mushrooms literally look different. Symbiotic relationships with trees create pathways for mushroom range expansion. Deathcaps form mycorrhizal associations with oak and other hardwood roots. As trees are transported for landscaping and forestry, their associated fungi travel too. Climate change allows these tree species to grow in new regions, and their fungal partners establish alongside them. Invasive tree species bring their associated mushrooms. When non-native trees are planted widely and successfully establish, they create habitat for fungi from their native ranges. These introduced fungi can include toxic species unfamiliar to local foragers. Seasonal timing changes affect fruiting patterns. Mushrooms that traditionally appeared in autumn might now fruit in summer, or traditional spring species might fruit earlier. Foragers using seasonal timing as part of identification criteria find this information no longer reliable. Predictive modeling attempts to forecast where toxic species might spread next. Climate envelope models use temperature, precipitation, and habitat variables to estimate suitable ranges for species like deathcap. These models suggest continued northward expansion in North America and Europe as winters warm. But predictions have uncertainty. We don't fully understand all variables controlling mushroom distribution. Soil chemistry, microbial communities, and complex ecological interactions influence whether a species can establish in new regions. Climate alone doesn't determine range. Suitable symbiotic partners, spore dispersal, and local conditions all matter. For foragers, the practical message is clear. Traditional local knowledge is no longer sufficient. Just because a toxic species never grew in your region historically doesn't mean it's absent now. Regular updating of local mycological knowledge is essential. Relationships with university mycologists or regional fungal surveys provide current information about species presence. Regional mushroom societies can track new species arrivals and alert local foraging communities. When deathcaps appear in new locations, rapid communication prevents poisonings. Citizen science initiatives documenting mushroom observations contribute to understanding range changes. The "it never grew here before" assumption is actively dangerous now. Climate change has made mushroom distributions dynamic rather than static. Expertise must continually update to account for ecological change. The foraging practices your grandmother used safely might not protect you today because the mushroom community has changed. This reality doesn't mean foraging is impossible. It means foraging requires ongoing education, humility about knowledge limitations, and engagement with current mycological science rather than static traditional knowledge alone.